Hello, Dr. Suhaila. So we are from Group 17, and I'm Chang Hock, and later we will have Stephen and Gary to explain our second projects for DES, ALU design for RISC-V CPU. So right now we can see this is a full design of our ALU design. So first we'll explain about the adder first. So for the 1-bit adder, it has three inputs. It has three inputs, which is A, B, and a carry-in bit, and this circuit is built using two half adders. So for the output, we can see we have a output for sum, and then an output for carry out bits. And then later we will see the simulation results. So for example, for the result at 4 microseconds, we can see the A and B and carry-in is the logic is 1. So 3 1 adds together equals 3 in decimal, and also equals 1 1 in binary. So we can see the carry out bits and the sum is both is 1. And then we'll proceed to the 4-bit adders. So this is the 4-bit adders. It also has, so the different thing about this adder is for the inputs AB and ALU OP. AB is a 4-bit input, however ALU OP is a 1-bit input. And then for the ALU OP, it is a controller to control whether the adder is perform the addition or subtraction. So if the ALU OP is logic 1, it will perform subtraction. If the ALU OP is logic 0, then it will perform additions. And for each of the carry out of the adders, it will become a carry in for the next adder, and the final carry out bit will be ignored. So now we will run the timing simulations. So when the ALU OP, just now what I mentioned, when the ALU OP is logic 1, it will perform a subtraction. So 1100 minus 0010 equal 1010. And later we will have Stephen to explain more about these projects.
Okay, my name is Stephen. Now I'm going to explain 1v4 to 1 multiplexer. Look at the logic circuit. We have the two selector signals, which are S0 and S1. And we also have the 4 input, A0, A1, A2, and A3. 0, 0, the output will become A0, and 0, 1, the output will become A0, A1. So let's look at waveform result. The run timing simulation. At 1, 0, the output will be A1. Next, I want to explain the 4-bit 4 to 1 multiplexer. 4-bit 4 to 1 multiplexer actually is the same concept with previous logic circuit. So we also have the 4 input, A0, A1, A2, and A3. The 4th input is 4-bit. And we also have the 1 selector signal, and the selector signal is 2-bit. When A selector is 0, 0, each 4 to 1 multiplexer choose the first input, A0. So the output will become 4-bit. So after run the simulation, so look at the selector signal. When selector signal A is 0, 1, then the output will become A1, which is 0, 1, 1, 0. So next, I invited my team member Gary to proceed their presentation.
I'm Gary. So right now I'll be explaining for the 4-bit D flip-flop, and as you can see, it is constructed using 4 1-bit D flip-flop. So each input is registered accordingly to its output, and the clock is synchronous, and the clear is a active flow clear. So it will only be clear when the input is 0. So after compiling the design, we will move on to the timing simulation. As you can see, the D flip-flop are preset to 1110, and at the rising edge of the clock, and when the clear is 1, so it will not reset, the Q output is registered as D, same as the input. So we'll be moving on to the final part. So this is our final ALU design. 2 4-bit 4 to 1 marks. So this is A and this is B, and each has 4 4-bit input and a 2-bit selector connected to one adder subtractor. This depends on the ALU op. When it is 0, it will perform subtraction, and when it is 1, it will perform addition. Finally connected to the 4-bit D flip-flop, and the output will be ALU out, which has a 4-bit. So right now we will compile our design. So we run the simulation. So for the clock, the interval is every 2 microseconds. Reset will set to 1 to ease things up so that we can have a better view of the simulation. And the ALU op is 0. So the ALU should act as a subtractor. So when the A selector is 1, 0, it should select A2. And B selector is 1, 1 should select B3. So 1, 0, 1, 0 minus 0, 0, 1, 0 will be 1, 0, 0, 0. So this ALU operation is correct.
So that's all from us. Thanks for watching.